Alright, this is topic 36, and now what we're going to do is we're going to find the equation of the tangent line at point 21. Alright, so remember, to find the equation of a tangent line we need a point, which we already have that here. Alright, but we also need to know the slope, and to find the slope we need to find the derivative here. Alright, and we need to evaluate that derivative at this point. So anyway, so the first thing we're going to do here is we're going to take the derivative of this, and remember, when you see something like this, I automatically think implicit, all right? Because this is not just explicitly y is equal to some equation. So I'm going to take the derivative of x cubed, which would be 3x squared, plus the derivative of y cubed. Well, that's going to be 3y squared dy dx. All right, sorry if I'm speaking too loud. I'll try to speak softly now. All right, on the next part, that's going to be equal to 4xy. So notice that that right there is going to be a product rule right here. You have x times y. You really have a choice. If you want to say that this is the first term, 4x, and the second term is y, you can. Or you can leave the y, you can leave the 4 out, like what I'm going to do actually. So I'm going to ignore that 4 for now. I'm just going to take the derivative of xy. Okay, so we have the first times the derivative of the second. Derivative of y is dy dx, plus the second, which is y, times the derivative of x, which is 1. Okay, so that's that right there. Plus the derivative of 1, which is 0. Alright, now I'm going to go ahead and try to distribute, add all the like terms. So we have 3x squared. So this does not change at all. Let's see, we have 4x dy dx plus 4y. Okay. Now remember, as before, we're going to get all the dy dx's on one side. Alright, so I'm going to skip a step here. Hopefully you don't mind. I'm going to subtract this to both sides, and I'm going to subtract this 3x squared from both sides. Alright, so what I have left is 3y squared dy dx minus 4x dy dx is equal to 4y minus 3x squared. And then now I am going to factor out dy dx. I'm going to factor that out. So I end up with 3y squared minus 4x is equal to 4y minus 3x squared. And then now I am going to divide both sides by this. Alright, so when I divide this side by this, that is going to cancel, and I end up with 4y minus 3x squared over 3y squared minus 4x. Alright, so remember that all I've done so far is I found the derivative. Alright, now to figure out the slope, and I'm going to write this here, to find the slope, plug 2, 1 into derivative. Alright, so what I'm going to do here is I'm going to plug in, or this is my derivative. And some people write it like this. You don't have to. They kind of write this as 2, 1 here, just to let you know that they're going to plug that in. So we have 4 times 1, which is the y coordinate, minus 3x is 2, so we got 2 squared, over 3, 1 squared minus 4 times 2. Alright, which is negative 8 over negative 5, which is 8/5. Right, believe it or not, I have a lot of kids do all this great work and then they'll miss it right here. Alright, if you happen to be using a calculator, please plug it into the calculator. Don't make a mistake. Alright, so that is the slope at that point. So remember, to write the equation we need the point. So we have y minus, well, I'll write this again, maybe you don't remember anymore. Y minus y1 is equal to the slope times x minus x1. Alright, so notice the y1 was given to me in the problem, so I have y, excuse me, we have y minus 1 is equal to 8/5 x minus 2. Okay, so that's the answer. Okay, so that's the equation of a line. Hopefully that wasn't too confusing. Let's go to the back. All right, and again, if I happen to go too fast, just rewind, but if you still have questions, make sure and ask me. All right, so whenever you see me. So this one, it says, given y squared equals to 4x, find the equation of the tangent line. So we're going to try to find the equation of the tangent line and the normal line. All right, so at x is equal to 1. So the difference now is, again, what do I need for the equation of a tangent line? I need a point and I need a slope. All right, now I have the x coordinate. I need to figure out the y coordinate. All right, so I'm going to write this over here because I may run out of room. So I'm going to plug in a 1 for x and try to figure out what y is. All right, y in this case would be equal to plus or minus 2, right? If I take the square root of each one of these, right, I get plus or minus 2. Okay, so it turns out that I could when x is 1, y is either 2 and negative 2. All right, so we have 2 points we have to look at. So we have to look at point 1, 2, and we have to look at point 1, negative 2. All right, so really this problem just became a little bit longer because of that. So I'm going to have to find 2 equations for each, the tangent and the normal. So now to figure out the slope, I'm going to take the derivative of this. This is, again, implicit. All right, so the derivative of y squared is 2y dy dx, and that's equal to 4. Now I'm going to divide both sides by 2y. That cancels that. And this is going to give me a 1 over, wait, that's not a 1 over, that is a lie. This would be 2 over y. All right, so that would be the derivative. So now to figure out the slope at 1, 2 would be, let's see, if I plug in a 1 here, I get 2 over 1. Excuse me. If I plug in a 2 for y, right, so I have a 2 over 2, which is 1. All right, and at 1, negative 2, I would plug in a negative 2 for y into this one, right? Notice that this one, the derivative happens not to have an x term, so I don't have to worry about the x term here. But this would be negative 1. All right, so don't forget what we found here. These are the slopes of the tangent line. These are the slopes of the tangent lines. Slopes of the tangent line at these 2 separate points. Okay, so these are the slopes of the tangent line. So now I have to write, and again, you don't have to do this. It just helps me keep everything separate in my brain. So I'm going to write the equation of the tangent line here. I'm going to write the equation of the normal line over here. Okay, so at 1, 2. And at 1, negative 2. Alright, so at 1, 2, I have the equation of the tangent line, which will be y minus 2, notice I'm using that number, is equal to, this is the slope, which is just 1, so I'm not even going to write it. Alright, so I have x minus 1. Alright, again, the slope is 1, so technically the slope would be out here if you really want to put it in there. But it doesn't matter if you don't, okay? Now the equation of the tangent line at 1, negative 2 would be y minus, plus 2, right? Minus a negative would make that a positive. It's equal to negative x minus 1. And you can leave it like that. Okay, you can distribute 2 if you like. It doesn't matter, right? Now hopefully the normal, the equation of the normal line, remember, we're going to have the same x and y values for the point. We have the point now. For the normal line, we have the negative reciprocal. Alright, so we have the negative reciprocal for the slope. So the negative reciprocal of 1 would be negative 1. So this is the equation of the normal line at 1, 2. And for this one, again, we have the same x and y. We have the same point. Now the negative reciprocal of negative 1 would be positive 1. So this one happens to be the same thing as what we had here. Okay? Hopefully that makes sense. Let's go ahead and go to the next part, because I think this is a part that could get a little confusing. All right, it says, where is the tangent line horizontal? All right? We can answer that, right? We know that the tangent line is horizontal where the slope is equal to 0. So remember, horizontal, if we have a horizontal tangent line, that means the slope is 0. Okay? So what we're going to do here is we're going to set our derivative. All right, we want to set our derivative, which was 2 over y. We're going to set that equal to 0, and then we're going to solve. All right, if we solve here, remember, the easiest way to do that, you can multiply both sides times the denominator, or you can cross multiply, if you will, assuming this is 0 over 1. All right, and when you do, you get the 2 is equal to 0. Now, 2 is never equal to 0, therefore, there is no horizontal lines. All right, so therefore, remember, those are the 3 dots, that's what that means. There is no horizontal tangent lines. All right, now for the vertical, all right, so that might be a little bit more difficult to understand. However, I know that for a vertical tangent line, the slope is undefined. Right? However, I can say that an undefined slope can be written as 1 over 0. Right, so I can write that as 1 over 0 if I like. Okay, and if I do have that, then what I'm going to do, which may look strange, is I'm going to set my derivative equal to an undefined slope, which I can rewrite as 1 over 0. And I'm going to solve for that. If I cross multiply, I get y is equal to 0. Okay, so that one right there. So we have a vertical tangent line at y is equal to 0. But when it says where is the tangent line equal to 0, they're actually looking for an x value. So don't forget this on a test. All right. So if I'm asking you where is the tangent line, normally, unless it's specified otherwise, when they ask for where, they want to know the x value also. Okay. So I want to figure out the x value. So what I'm going to do is, I know that the vertical tangent line is located at y is equal to 0 on the original function. All right, so the original function, if you remember, was y squared is equal to 4x. All right, so we're going to plug this in. So we're going to plug y is equal to 0 into original function. Or you can call it, actually I don't even know what else to call it. Function. All right, so that would be 0 squared is equal to 4x. Long story short, through the magic of television, x is 0. Okay, so we have, therefore, we have a vertical tangent line, that is, at x is equal to 0. All right. Now let's go ahead and go to this very last problem. Let's go to this last problem here. So they want us to find the second derivative. So don't forget that this right here means the second derivative. I still have some students that when they see something like this, they don't know what to do, right? Remember, don't make it harder than it is. It's just the second derivative. All right, so let's do this. Let's go through this one relatively quickly here. First, to figure out my second derivative, I'm going to write my first derivative, which was 2 over y, and this is actually not too bad, hopefully. All right, which I can also rewrite as 2 times y to the negative 1 power. And then now I can just use the simple power rule, right? So my second derivative. So remember, this is just the notation for the second derivative of y with respect to x. So that's just the notation for that. I'll use the power rule here. So I have negative 1 times 2. We'll make that a negative 2. Okay, and I'm going to subtract 1 from this power. Now, because I'm still taking the derivative implicitly, all right? This is still, I'm taking a derivative of y with respect to x. So this one also has a dy dx. Okay? So at that point, you may think, well, I'm done. Well, no, because I don't want to have another derivative within this second derivative, all right? So what we have to do is actually very simple. We're going to substitute. All right, so we're going to substitute this dy dx here that you see here. We're going to substitute that with 2 over y, which was dy dx. See, dy dx is 2 over y, right? So I can rewrite this dy dx like this. And then now, let me maybe write it so you know what is happening here. Substitute dy dx, which is equal to 2 over y. That's what happened there. Okay, and then now we're just going to do some simple algebra here. You can do it in however many steps it takes you. This would be y squared times 2 over y. This one's going to be negative 4 over y cubed. Remember, because when you multiply the two denominators, you're going to add the exponents. Okay? Now, please, if you have made it all the way to the end of this video, or are you still listening, please read the instructions on the homework. You're not just taking derivatives, all right? Please read the instructions. Do it on a separate piece of paper also. This is not a challenge. This is a command. All right, if you got any questions, ask me tomorrow. Hopefully this was easier to understand.